Okay, practice problem number 2 for 1D motion. So, we're told that a driver who is stopped at a traffic light, then once the traffic light turns green, accelerates with a constant 1.7 meters per second squared. And the driver passes through two intersections. So let's say this is intersection number 1, and this is intersection number 2. And we're told that the distance between these two intersections is 75 meters, and that it takes 7.2 seconds to go this distance. So that's the displacement, and the time to do this is 7.2 seconds. Now, we're going to want to know what is the velocity when it passes through the first intersection. I'll call that one v1, and when it passes through the second intersection, so I'll call that v2. It's tempting to say, well, v1 has to be 0 because that's where she started. Well, maybe he or she, the driver, started earlier than that, and these are intersections following that traffic light. So I'm not going to make that assumption. And so I've got two unknowns. Equations to use, well, one using the two velocities, the acceleration and time, would be, let's see here, that the second velocity would equal the first velocity plus the acceleration times time. Secondly, we might use the acceleration, the two unknown velocities, and the displacement. And that equation is that the second or final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. And now we have two equations with two unknowns, so I would treat this as a system of equations. I can replace v2 with this quantity, v1 plus at, right here. And so what we end up with is v1 plus at quantity squared equals v1 squared plus 2a delta x. And notice now our only unknown is v1, which is what we're looking for in part A. So squaring out a binomial, don't forget there's a middle term. So this becomes v1 squared plus 2v1at plus a squared t squared equals v1 squared plus 2a delta x. And in this case, we have v1 squared on both sides, so we can subtract that out. And now we can solve for v1. So 2v1 times at equals 2a delta x minus a squared t squared. So v1 will equal 2a delta x minus a squared t squared, all of it divided by 2at. Okay, so now we can plug in numbers, and when we do so, v1 turns out to be 4.3 meters per second. So there's the answer to part A. We can now take that and substitute this value back up here for v1 and find that v2 is equal to 16.5 meters per second.